All right. A linear inequality is of the form ax plus by is less than c, or ax plus b, excuse me, or ax plus b is greater than c, or ax plus b is less than or equal to c, or ax plus b is greater than or equal to c. Now, solutions to these will consist of saying x less than a, x bigger than some a, x less than or equal to a, x greater than or equal to a. We'll solve this for x by means similar to the ones we've used before for equations. Now, x less than a, that inequality like that, its graph is all points to the left of the point A, but not including A. And I denote that by an empty circle. We denote this by in what's called interval notation. Bracket negative infinity to A. This goes from infinitely to the left up to A, not inclusive. X greater than A, its graph does not include A and does include everything to the right of it. Not including is denoted by an empty circle. And its interval notation is parent A to plus infinity. Everything bigger than A and less than positive infinity, like this. X less than or equal to A includes everything to the left of A and A, which we denote by a filled in circle, like here. And the interval notation is round bracket negative infinity to square bracket. Round bracket means we don't include A, square bracket means we do include A. And neither of these do we include in negative infinity because it's opposite to infinity. We don't consider that a number, really, a normal number. And then x greater than or equal to A includes A, filled in circle, and everything to the right of it. So that's denoted square bracket A to positive infinity, round bracket. These are all half lines. These are half lines that don't include the endpoints, and they're called open half lines. These do include the endpoints, and these are called closed half lines. You solve a linear inequality by turning it into a half line by these rules. One rule is that if you have an inequality, then you can subtract the same number from both sides, and it stays the same inequality. A less than B means A plus C is less than B plus C. A minus C is less than B minus C. So if 2 points are in a certain order, then you move them both to the right or both to the left, then it's still the same order. And not just less than, but also greater than, less than or equal, greater than or equal. If A is less than B and C is positive, then you can multiply both sides by C and divide both sides by C, and it stays in the same order. So multiplying by positive and dividing by positive preserves order. But if A is less than B and C is negative, then multiplying or dividing by C reverses order. A less than B and C negative means that AC is bigger than BC, and A over C is bigger than B over C. So multiplying by a negative and dividing by a negative reverses order. So here we go, some examples. Solve and graph. 2x minus 7 is greater than or equal to negative 29. Okay, if this were an equation, we'd transpose the 7 and then the 2, and we'll do the exact same thing. We'll add 7 to both sides. 2x greater than or equal to negative 29 plus 7. Same inequality, greater than or equal. So 2x is greater than or equal to negative 22. Now I'll divide both sides by negative 2, and since it's a positive number, the inequality stays greater than or equal. X is greater than or equal to negative 22 over 2. So x is greater than or equal to negative 11 is the inequality. Its graph is everything to the right of and including negative 11. The interval notation is bracket negative 11 to positive infinity parent. Here we have t plus 1 minus 3t is greater than or equal to t minus 20. Okay, I'm going to move the 1 to the right by subtracting from both sides, and then this t to the left by subtracting t from both sides. And since these are just subtractions, the inequality stays the same. So you get t minus 3t minus t greater than or equal negative 20 minus 1. Okay, combined terms, negative 3t is greater than or equal to negative 21. Now we divide both sides by negative 3, and dividing by a negative reverses the inequality. So this greater than or equal becomes less than or equal. So you get t less than or equal to negative 21 over negative 3. So t is less than or equal to 7 is the inequality. The graph is everything to the left of and including 7. Bracket, negative infinity, parent, negative infinity, parent, comma, 7, bracket. Okay. Here we have 4 less than or equal to 9/10 x plus 1. Subtract 1 throughout, that keeps the inequality the same. So you get 4 minus 1 is less than or equal to 9/10 x. That's 3 less than or equal to 9/10 x. Now we'll get rid of this 9/10 by multiplying by the reciprocal. That will cancel it out on the right. Because 10/9 is positive, the inequality remains the same. So 10/9 times 3 is less than or equal to x. And this multiplies out to 10/3. So 10/3 is less than or equal to x. It's everything to the right of or equal to 10/3. Bracket, 10/3, positive infinity, parent. 3/4 times x minus 3 is less than 1/4, 1/3 times x minus 4. Well, these fractions, particularly these denominators, are annoying. So let's multiply by 3 and by 4. And so in other words, by 12. And 3 and 4 and 12 are positive, so the inequality stays the same. So 12 times 3 over 4 times x minus 3 is less than 12 over 3 times x minus 4. After some canceling, you get 9 times x minus 3 is less than 4 times x minus 4. Okay. Distribute the 9 over this, the 4 over that. Get 9x minus 9 times 3 is minus 27, less than 4x, 4 times negative 4, minus 16. 9x minus 27 is less than 4x minus 16. I will move the 27 to the right and the 4x to the left by subtracting 4x from both sides and adding 21 to both sides. Since these are just additions and subtractions, the inequality sign remains the same. So 9x minus 4x is less than negative 16 plus 27. So 5x is less than 11. Now you divide by 5, which is a positive number, so the inequality remains the same. I get x is less than 11/5. The graph is everything to the left of and not including 11/5. The interval is parent, negative infinity to 11/5 parent. Here we have 2 times 5x minus 6 is greater than 4x minus 15 plus 6x. First you distribute. 10x minus 12 is greater than 10x, so combine these 10x minus 15. So move this 10x to the left by subtracting it. Move this 12 to the right by adding it to both sides. The inequality remains the same. 10x minus 10x is greater than negative 15 plus 12. Or 0 is greater than negative 3. This is the equivalent of a singular system when we're doing equalities. Here we look at it. Is 0 greater than negative 3? Yes or no?
What was the question?
Here, after we simplify this, 10x minus 10x is a 0. Minus 15 plus 12 is negative 3. So you get the inequality 0 is greater than negative 3. Now this doesn't mention x at all, so it's true for all x or for none of them. And now I ask you, is 0 greater than negative 3 or not?
Yes.
Yes. You'd rather have $0 than $3 of debt, right? So okay, 0 is in fact greater than negative 3 for any x. So therefore, this is true on the entire line from negative infinity to infinity. If I had wound up with 0 less than negative 3, that would be true for no x. Here we have 5x plus 2 over negative 4 is greater than 5x plus 1 over negative 4. Okay, multiply both sides by negative 4 and these cancel and the inequality sign reverses. 5x plus 2 is less than 5x plus 1. Subtract 5x from both sides, subtract 2 from both sides. That keeps the inequality the same. So you get 5x minus 5x is less than 1 minus 2. This becomes 0 is less than negative 1. Okay, is 0 less than negative 1?
It's false.
It's
No.
false. It is, yeah, correct. So it's false for all x. So therefore, this is known as an empty set. This is true for no x's. Okay, here we have a dunking tank for a school. And it's $85 to rent for the first 3 hours, then $19.50 per hour for each additional hour or part thereof. So how long can the tank be rented for $185? The first 3 hours cost $85, so there's $100 to go. 2 hours later, or part, costs 19.50 T. So 19.50 T is less than or equal to 100. So divide by 19.5, the inequality stays the same. So T is less than or equal to 100 over 19.5. T is less than or equal to 5.125205. Now, okay, or part thereof means that we have to round off. We have to delete this. We want to find the biggest whole number less than or equal to 5.12, etc. It's fine. 6 hours would be bigger than this, so it won't work. So total number of hours is 5 hours plus the first 3 hours is 8 hours.